Hello guys, and welcome to this new video, which is going to be a complete MySQL crash course. So the intention in this video is to show you all the necessary basics that I believe every person wanting to learn SQL should be able to know in order to take you from a complete beginner level to a level where you are at least comfortable in writing various MySQL commands. So before we get started with the actual implementation or writing of commands, I want us to first of all go through some theories under SQL and MySQL. So here I have some brief definitions I want us to first of all understand. The first thing is going to be a database. So when we talk about a database, it is simply an organized collection of data arranged to facilitate the manipulation and retrieval of data inside this organized collection. So what we mean by this is that a database is simply a place where we store data, and then it is so well arranged such that any particular piece of data that we want to have from this collection, we can be able to easily access it and remove it, or do whatever thing we want with it, like modifying or even deleting it. Now we have two main types of databases that exist. The first type is the relational database. This is a database which uses tables to store its data, and each table is arranged as rows and columns. It also uses SQL, which stands for Structured Query Language, to interact with the database. This means the commands which you are going to be writing in order to do various things in your database are going to be written in a language known as SQL. And examples of relational databases are Oracle database, Microsoft SQL Server, and SQLite. The next type of databases that exist are the non-relational databases. A non-relational database is a database that does not use tables to organize and store its data. There are different types of non-relational databases, and each type uses its own different method or technology for organizing and storing data. So non-relational databases do not use tables for organizing data, and they don't also use SQL to interact with the database. Some popular examples of non-relational databases are MongoDB and Redis, which we are not going to talk about in this video because here we are focusing on relational databases only. And the next concept is a database management system, or a DBMS for short. A database management system is a software application that facilitates the creation, maintenance, and use of a database. So it is simply a software application that we use in order to create, use, and maintain databases. A very popular example is MySQL, which is what we are going to be seeing in this video. MySQL is a database management system for relational databases, meaning that it is a database management system that enables us to create and manage only relational databases, not non-relational databases. So with that being said, we can now start writing or talking more about MySQL. So for this video, I am using MySQL Workbench as my DBMS, and the MySQL DBMS comes in various forms. It can be as the command line interface, which is the one with a dark screen where you write all the commands, and it can also be as the workbench. So here I am using the workbench because it is more beginner friendly and it is more suitable for beginners because they can easily write and edit commands without having to restart every command each time. So for those who don't have MySQL Workbench yet, you may want to first install it. I'm going to leave a link in the description for a video that shows you how to download and install MySQL Workbench. But for those who already have, we are good to go and continue with the video. So I'm going to first open my Workbench, and then I will choose a connection instance here. Okay, now we are inside our MySQL Workbench editor, and we can see various things here. The first part we can see is the middle part. This is where you are going to be writing all our SQL commands to interact with our databases. And on the left side, we have various things that are not really important for this video. So we are going to focus mainly on writing our commands and interacting with our databases here. So when you install MySQL Workbench or MySQL, it by default comes with some number of databases which are available inside your Workbench. So in order to see all your databases, you can use a command which is known as the show databases command, written as show databases. As I said, the show databases command is a command to see all the databases which you have already created or which are already existing inside your MySQL workbench. And we can notice some things from this command. The first thing is that every command in MySQL is supposed to end with a semicolon. So the semicolon is what indicates that you have reached the end of your command, and if you write a command without a semicolon, it won't be able to run. Secondly, you can see that I have written my command in uppercase characters. This is because in MySQL, it is generally advised by convention to write all keywords in uppercase characters while non-keywords are written in lowercase characters. What I mean by keywords are words that are already predefined in the SQL language to mean or do certain specific things. Like when we say show databases, this command contains two keywords which are show and databases, and our SQL language already understands that when it sees these words, it knows what each of them means already, and this command is going to do something specific. So I'm going to run this command, and we can see our taskbar in the MySQL editor here. We can see various things. We can save the file, or we can even run. So to run the file are these two icons that look like thunder icons. The first thunder icon is clicked when you want to run all the commands which are currently available in your command editor, while the second one is to run a single command. In order to know the single command which we want to run here, it is simply going to be the command on which your cursor is currently, or the line on which your cursor is currently. Like here, our cursor is currently on the show databases command, so if I click on this, it's simply going to run this command. So let's do that, and we can see all the available databases that are shown in our results. And we can also notice that in the below the results, we have a green tick with a message which shows that our show databases command has been executed correctly. Now this show databases command shows us all the databases which are already available, but we can also create our own using the create database command. So I will say create database. So these are also keywords in SQL. And now I'm going to give my database name which I want. So the database name is going to be footballers. So I'm creating a database called footballers, and I will end my command with a semicolon. Now this footballers, which is the database name, is an example of a known keyword because this word has been given by us and it is not recognized by SQL to mean anything specific. It is simply an identifier that we are giving for our database. And I'm going to run this command, create database footballers, and we can see that we receive a message with a green tick that says create database footballers is executed successfully. Now let's run the show databases command again to see the new footballers database that has been added. So we can see in our databases we have football players. This one was a previous database I already created, but this is the new one that has been added, footballers, and this is what we just created. So our database is created successfully. Now it doesn't just suffice to create a database and leave it like that. If you want to actually interact with a database by writing different commands that are going to be executed, we need to select the database which we want these commands or these modifications to be applied on. So for that reason, we are going to use another command which is the use database command. I will write use. It is not actually use database, it is use followed by the name of the database you want to use. So I will say use footballers, follow it with a semicolon. So when I say use footballers, this means we are trying to enter the footballers database so that any modification or any command that we write to modify something in a database, we should know that these modifications are supposed to be made inside the footballers database. And if we want to then continue working with another database, we simply use this same command use, and instead of footballers we write the name of the other database which we want to enter at that moment. So I will run the use footballers command, and we also see the success message. This means now we can use or write commands inside the footballers database. Now when we have already selected our database we want to write commands in or we want to work in using the use database command, the next thing we have to do is, since this is a brand new database footballers which we just created and there is nothing inside, we need to first create a table, at least one table inside of this database, so that we can be able to store data in it, because as we said, with relational databases, we organize our data in the form of tables, and without a table, you cannot store anything in it. So everything you store in this database is going to be under a particular table. So in order to create a table, there is also a command for it. It is going to be create table, and after create table you then give your table name. So I want to create a table for players. I will just say players like this. So the database name is footballers, but the name of this particular table is players. And after this I will give a set of parentheses. Now inside the parentheses I am going to specify what we know as the table attributes, or in other words, the name of the various columns of the table. So we know that a table, for those who are familiar with something like Microsoft Excel or even HTML, we know that tables usually have different columns and each column has a column heading. So in this place it is where we are going to specify or define our column headings or the different headings we want to have in this table. And these headings in SQL are going to be known as table attributes. So for our players table, I want each player to have the various things. The first thing is going to be an ID. The ID is going to be an attribute that uniquely identify each individual player in the table. And after writing the column name, I will have to write some set of SQL attributes again after this. So I'm going to give the data type of this table column, which is called ID. And the data type is simply a keyword that is going to indicate the kind of values that this table or this column is allowed to take. So the ID here is simply going to be a value that is going to be unique for each and every player in this table, such that if I want to access any player, I can simply reference that particular value to get the player that I want. And for that reason, they need to be unique, as I said, because if we give the same ID for two different players, it is going to cause confusion in our database, because the database won't know which value to return to us when we try to access that particular ID. So for the ID, I'm going to use numbers as my ID, where each player is going to be represented by a particular number. And to give number values as data types for a particular column, we can use a data type like int, which stands for integer, and this represents all integer values or whole numbers. And after this, I want to also add another attribute for this column, which is going to be the primary key attribute. So the primary key attribute is an attribute that tells us that we want this particular column to be a primary key, which means that it is going to be a column which does not have any repeated values, and it is used to identify every individual player inside this table. So these are the two attributes that I'm going to give for this column, which are int for the data type and then primary key to say that it is the primary key of this table. And I will write a comma, go to the next line, and I can write another column again. So the next column is going to be the name. So after the ID, each player is going to have a name. I'm going to say the name and the data type for the name. Each column needs to have a column name and a data type. So for the data type for the name column, I'm going to give varchar. So the varchar is a data type that enables us to store values that are made up of text. Like we know things like names of persons or different places are going to be a sequence of letters. Like if somebody's name is John, for example, John is made up of 4 different letters, and those type of letters are what we call text. So the varchar is a data type that we use to store text values. And after varchar keyword, I will write a set of parentheses, and within this parentheses I'm going to give the maximum number of characters that I want each person's name to have. So here I'm going to give 50. It means each name should have not more than 50 characters, but they can have less. And I'm going to also add another attribute, not null. So the not null is an attribute that we give or we write on a column to specify that we don't want this column to have any null values. A null value is simply a value that does not have a particular thing or a particular value that we have entered inside. For example, if we are creating a particular player and we don't give a value for the player's name, it is not going to allow that player to be created because of this not null attribute. But if we don't precise not null, we can be allowed to create a player without giving a name for that player. But since I want every player to have at least a name, I will say not null, so that if we create a player without a name, it shouldn't work. And for the primary key attribute, by default primary keys are not null already. So when we write primary key here, by default it makes that this column should be not null, so we don't need to write not null again because a primary key cannot be null. And I will write a comma to give another column in our table again. So let's say I want to also have the height of a player. I'm going to write height, which is the column name, and the height is going to be a number. Generally we write height as decimal numbers, like somebody's height can be 1.2 meters I'm precising height in meters, not height in inches or any other measure. So the height can be a decimal value. For that reason, I will write the decimal data type. So decimal is a data type that allows us to write decimal values or to give decimal values to different columns. And here we are going to also follow this with a set of parentheses, and the decimal takes two things inside this set of parentheses. The first thing is going to be the total number of figures we want this decimal value to have, and the second thing is going to be the number of decimal places inside that figure. Like for example, we want to have a decimal value for the height, which is going to be to 2 decimal places. So that means overall there will be 3 figures inside that decimal value, and 2 of them will be after the decimal point since it is to 2 decimal places, while the other one will be before the decimal point. So for that reason, I write 3,2. This tells us that there are 3 figures in total and 2 of them are after the decimal point. And I will write a comma, and lastly we are going to have the jersey number for the player, or I will just say number instead of jersey number. The data type for the number is going to be an integer because numbers are usually integers. I've never seen a football player with a decimal number, so we already know what int represents, which stands for integers or whole numbers. And then I want this to also be not null. This means that we cannot have a player inserted without a number, or let me actually write this as jersey number for more clarity. And notice that as I've written jersey number, the column name is made up of 2 different words in total. It is not a single word like the other columns like height, name and ID. So in a case like this, we have to use an underscore to link the 2 different words because it cannot be an empty space like that. If not, it is going to cause an error. So we need to link them with an underscore. Or another way, if we don't want to use the underscore, is that we write the first word, and for the second word we write its first letter in an uppercase character. But I prefer using the underscore because that's what I like more for this particular case. So we are going to continue like that. After the jersey number, I will not add a comma because this is the last column that I want to use for this table. So the comma is going to cause an error here because there is nothing that will follow under. So I will just cancel the comma and we can end the command like this, and I will come where the command ends, which is the closing parenthesis, and I will put my semicolon here. Remember that every command needs to end with a semicolon. So in order to run this, I can simply click on this my icon here to run or to create the table called players. Now we see we get a success message below which says create tables players command has been successful. And now let's say if I want to see all the tables which are currently in my footballers database, we know it is just one table, which is the players table which we just created. But if you want to see all the tables in this database, we can use the command show tables, and it is going to show us all the existing tables in this database, which I'm going to run. And now we see we have the footballers database, tables in footballers, and we have just one table which is the players table. Okay, so now we have seen how to create a table using the create table command, and we have even seen how to display that table or to show the table using the show tables command. Now we are going to see how to delete a table. For example, we want to delete this players table from our footballers database. We can use another command which is the drop table command. So I will write drop table, and then after this I will give the table name which I want to drop, and I will write players. So this means I want to drop or delete the players table, and remember that a semicolon is necessary at the end. And if I run this command, we are going to see that we have a success message which says that the table players has been dropped or deleted successfully. Now I can also drop or delete the entire database using another command which is the drop database command. So I will say drop database. So we see say drop, instead of tables we simply say database, and then I will give the database name which is footballers. So if I run this command, it means we are going to delete this our entire footballers database, but I will not run this one because I don't want to delete the database, but I was just writing it for the sake of showing you guys. Now we have already dropped our players table, and I actually want to recreate the table back, so I can simply come and select this our create table command to recreate this table for us to continue with the video. But before I recreate the table, I actually want to add one last attribute on this table, or one last column, and which is going to be the date of birth. So I write a comma after null, and I will go to the next line and say date of birth. I can just write date of birth as DOB because I don't want to write too much, and then let me write it in capital letters since it is an abbreviation. So I will say date of birth. The data type for date of birth is going to be the dates data type. So there is a data type in SQL for storing dates, and I will not give not null here because I don't want the date to be obligatory, so I will just end it there. And now I can select the entire table command and I will run it again to recreate the table. And now the players table has been recreated. Now let's use our show tables command to see if we are going to see this table there. And we see that there is a table players in our footballers database, correct? Now that we have already created a table, it doesn't just suffice to create the table and leave it like that. We need to actually insert data in this table in order for it to have any use or make any sense for us. So we are going to see how to insert data in a table now, and it's going to be done using the insert into command. So I will first cancel this line here because it's not necessary. And to insert data into a table, we use the command insert. So we have insert, and I will follow this with another keyword into. So we are saying we want to insert into, and after that I will write the table name in which I want to insert something, which is players. Now after the table name, we write a set of parentheses, and within this parentheses we write all the values which we want to insert. So I will first specify the different columns under which I want to insert something, and I will just write all the columns of the table here, which are ID and then name. What other columns did we have again? So we have ID, name, height, jersey number, and then date of birth. So I will say height, jersey number, and finally date of birth. Now after writing all of this, I will go out of my closing parenthesis and I can go to the next line in order for this to be more readable or clearer, and then I will write values. You must not go to the next line, I'm just spacing it out by preference. Values is with one L, sorry. Values. Now after values, another set of parentheses, and here I will now give the values which I want to be inserted under these different columns. So the first value is going to be the ID. I'm going to give the value of 1 for the ID for the first player, and comma, second value to give is the name. The name is a voucher, which is a sequence of text, so I want to write this within double quotes because that is how vouchers are written. I will write within double quotes, and the name of the first player I will write will be Lionel Messi. Now for the height, I am assuming that the heights are in meters, so I will just say, I don't know much about this, I will just say let's just say 1.5 meters, but I will not write the M after, I'm just writing the value. And for the jersey number, Messi is number 10, so I will write 10. Now for the date of birth, the date of birth has a particular format it is supposed to be written in, and to write the date of birth, we are going to first start by writing the year of that date. So for the date of birth, I actually did a little research on some few players' date of birth which I am going to use here. So for Lionel Messi, he was born in, the year is 1987, so I write 1987 and with a hyphen. After the year, we have to write the month, which is June. So June is 06 because it is the 6th month of the year, and followed by the actual day, which is the 24th. So he was born on the 24th June 1987, and that is how we are going to represent it. So that is going to be the date of birth of our first player in this table, and actually this has to be written within quotes. We can either use double quotes or single quotes, but I will use single quotes because that is what I generally use most of the time for this type of things. So for my personal preference, I usually reserve double quotes for vouchers or text, while things like date of birth, I use single quotes, but it's my preference, as I said. And I will follow this with a semicolon at the end of the command to show that the command is over. Now I will simply click on our icon to run this command and insert this player in our table, and this insert message has been successful. So we have inserted one player in the table already, and we can actually see if this player has been inserted by trying to view the table, and we are going to do that with another command to query the table or to see everything that is inside our table. I will write the command select. So the show tables command, it simply shows us the tables that are existing inside the database, but if I want to see more details about a particular table, I will say select and then star from, and followed by the table name, which is players. Now let me run this command again, and we are selecting everything from the players table, and we see the first player has been inserted, which has the ID 1, name Lionel Messi, height 1.50 meters, as I said, jersey number is 10 and date of birth is whatsoever is there. And we can see under we have null values everywhere on all the columns of the second row, because the second row does not have any inserted player yet, so it has by default given null values everywhere. And as I said, a null value is a value that is given to a particular attribute or in a particular place if no value for that attribute is given. But if we specify that attribute as a not null, we won't be allowed to give or to leave that space empty, and we will be given an error saying that the value must be inserted. So let's insert a second player. I will use this same insert command, but I will simply modify the values. So for the name, I'm going to change this name and insert a second player, which is Cristiano Ronaldo. For the height, I think Ronaldo is much taller than Messi. I'm not so sure of this, but let me just put 2 meters. And jersey number, I'm going to put 7. For his date of birth is February 5th 1985. So I will start by giving the year first, which is 1985, and a hyphen, then the month, which is February, that is 02, because February is the second month of the year, hyphen again, and followed by the day, which is 05, because it is February 5th. Now for the ID, I'm going to change it to an ID 2 because it is the second player in our database. And for the sake of practice, let's insert a third player. I will give the player the ID of 3. Name will be Neymar Jr. Height, I will give 1.7. I'm not sure he's as tall as Cristiano. And for the jersey number, it will be 10. Date of birth, Neymar's date of birth is February 5th 1992, so I will write 1992 in the place of the year. February 5th, they remain the same. It is quite funny that he has the same day of birth as Cristiano, and I will leave this like that. Now let me remove one of the attributes which are not obligatory. So I'm going to remove the height. I will not insert anything for the height here. So I will not insert anything for the height here. I'm going to remove 1.7 from here, and if I remove 1.7 from there, I need to also remove the attribute height from the insert command. So I will remove height, specifying that I don't want anything to be under the height. So I have just ID, name, jersey number, and date of birth. So we are allowed to do this because height is not an obligatory attribute, since we did not write not null on it. And take note that when inserting these values, the order must be exactly the same, because you cannot write ID followed by name, but in your values you are inserting name before ID. It is going to cause a mix-up which will give an error. So we need to take note of the order and make sure that it is exactly correct. And I will run this to insert the last player. Now I will select from our players table again, and we will see all the players that are inserted there. Now we see we have the first 2 players with all the attributes, but for the third player, Neymar Jr., the height is not given. That is why it is null, and he has all other attributes correct. Okay guys, so we have seen how to insert players into a table with enough examples. Now let's see how we can query from a database. As I already said, querying from a database is simply asking our database to give us a particular piece of information that we want, and it gives it to us if it is found inside the database. So this is an example of querying a database where I wrote select from players, because we are asking the database to give us everything found in the players table, and the result it gives us is what it returns as what we asked for. Now we can actually do more with this. Here we are simply selecting everything from the players table as we already saw, but instead of writing this asterisk, the asterisk is to specify that we are selecting everything from this players table, but we can actually write individual columns that we want to select from this table. So for example, I can say I want to select the name and the jersey number of every player only. So I will say select name. I can select only the name if I want, as well as I can also add other attributes. So I will say name and jersey number. So I'm selecting the name and jersey number from players. It is going to return only the names and jersey numbers of each players. As we see, you have only 2 columns return name, jersey number, with each of the players having their own unique details. Now let's see how we can also rank table elements in a particular order. We are going to do this by adding another keyword in our select command, which is going to be order by. So normally when we write a command like select name, jersey number, and so on from players, and we run this command, by default it selects or displays us the players in the order in which they were inserted. That is, we see the first is Lionel, second is Cristiano, third is Neymar. This is because that is the order in which they were inserted, and they have the IDs 1, 2, 3 respectively. So we can say it displays with respect to their order. But what if we want to display them based on another order which is not the default insertion order? In order to do that, I can use the order by attribute. So I will say from players and then give some space and write order by. There's actually a space between order and by. So what I'm saying here is that I want to select the name and jersey number from players, but ordered by another attribute instead of their default insertion order. So I'll give the name of the attribute which I want to rank them by, which is going to be the jersey number. And after that, I will give the direction order, which is going to be either ascending or descending order. So it's either I want them to be ranked from the least or from the person with the smallest jersey number to the highest jersey number, or I can also rank from the highest jersey number to the smallest jersey number. So if I want to go from the smallest to the highest, I use the keyword ASC for ascending order. And if I run this, now we see Cristiano is the first player because his jersey number is the least, which is 7, while the other two have 10, 10. And if I change ASC to another keyword, which is DESC, this one means descending order. It means the highest jersey number will be displayed first, while the least will be displayed last. And now we see Cristiano is the last because he's the only one with a jersey number of 7, which is the least. And if we don't write any particular order we want, with like ascending or descending, by default the order is going to be ascending. So if you want to use ascending, we must not even write ASC again. Now we can also order by another attribute, which is, instead of jersey number, I will say name. So here we are saying that we want to order by the name instead. And since the name is not a number, it is going to now check the alphabetical order of these names. So the person whose first name begins with the earliest letter in the alphabet is going to be first, and vice versa. So here I'm ordering by name, and as I said, if we don't write any specification, by default it is going to be ascending order. So let's order this by the name and see. And here Cristiano Ronaldo is the first again because his name begins with a C, which is the earliest among all the others. And now let's also talk about aliases in MySQL. I will first expand this my screen a bit to give more space. Now let us talk about aliases in MySQL. And an alias is a way of selecting values from table columns, just as we have. Like when we select this our attributes or this our values, if you look very well, you have the table columns above, which are name and jersey number. But if you want this result to be displayed, but instead of the default column name of this column name, we want something else to be given in this place, we can use an alias for that. So I will say I want to select name, and I will say as in capital letters because it's a keyword. I am selecting name as player name, and I want to also select jersey number as, I will just say number, or instead of number, let me give player number. So what this means is we are, instead of the attribute or the column names name and jersey number, we are going to be displayed this same result but with the column names player name and player number instead. And take note that this is going to simply display only the result with these new column titles, but it does not mean it is changing the column titles in the actual database. It is just for this single result that is displaying. And we see now we have the column names displayed as player name and player number instead of name and jersey number. And as I said, take note, it is not modifying the actual column names in our database. It is just showing a different column name for the sake of this particular result only. Now before we go to the next thing, let me cancel some of the things here in order to create space for our commands. So I will cancel all the aliases, and I want to simply select name and jersey number, name comma jersey number from players, and I'm not going to even order again. Now what I want to show you is how to use the distinct keyword. So we see that in our result we have two players with the same jersey number, which are Messi and Neymar Jr. with the jersey number of 10. Now what if I want to see the different jersey numbers that are made use of in our database or in our players table, without having to see all the repetitions, that is, without having to know how many players actually have that given jersey number. I just want to see only the jersey numbers that have been used. So for that, I can select the jersey number from players, and I'm going to write a keyword, which is, first of all, without the keyword even, let's just run this and see what it is going to give. We see it gives 3 jersey numbers, 10, 7 and 10, but we see that when we already have 10 and 7, the last one is still 10 again, and we already saw that there was 10 in the database. So I can select jersey numbers from players and write the keyword distinct. So this means it is going to only give us the jersey numbers which have been used without writing the repetitions. That is, if it writes a number once, even if it occurs 100 other times again, it will not display it 100 times again, because it has already told us that there is this number 10 inside our database. And actually this distinct, it is not supposed to be at the end. I will cut it from here, and it is going to be right after the select keyword. So it is select distinct jersey number from players, and I will run this. Now we get only 10 and 7 because those are the only 2 jersey numbers that have been used. Now let's also see how we can select data from a table following a given criteria. So we can want to select maybe given columns from a given table, but we want to see only the values that meet a given criteria. In that case, we are going to use a keyword which is the where keyword. So let me say I want to select not only jersey number, but I am selecting the name and let's say jersey number again. I want to select name and jersey number from players, but I will say after players I will give a keyword where, and here I will give a condition now. So I don't want to just select the name and jersey number of all players, but I want to select the name and jersey numbers of players where the jersey number, for example, is equal to 10, and I will run this. Now we see we are displayed Lionel Messi and Neymar Jr. only because they are the only 2 with jersey number equal to 10. And instead of comparing just exact values like this, I can also say where jersey number is, let's say, greater than 7. So you see I'm actually using a comparison operator here, and I will run this again. We see Lionel Messi and Neymar Jr. are still displayed because their jersey numbers are greater than 7, but Cristiano is exactly 7, so it is not displayed. I can also say jersey number less than or equal to 7, and we see only 1 player will be displayed now, which is Cristiano Ronaldo. And instead of checking the condition with my jersey number, I can also check with another attribute like the name. I want to select all players where name equals Neymar Jr. So since the name is a varchar or a text, I will write it within double quotes and I will say Neymar Jr. And we see only 1 person is displayed. And I can also see, let's say I want to select where name equals just Cristiano. We see we have no player displayed because there is no player with the name Cristiano. We do have Cristiano Ronaldo, but just Cristiano doesn't exist. And so we see how it goes. We can select with a condition simply by adding a where after our command. At the end of the command we write where and we give the condition that we want here. So we have seen how to select from a given table using a condition, which we have done with the use of the where keyword which we have here for specifying the condition. Like here we are selecting the name and the jersey number from the players table where name equals Cristiano. As we can see, nothing was returned, but I can also give another condition which I want to check alongside this particular condition, name equals Cristiano. And in order to do that, I can simply give a space after this, and then after name equals Cristiano I can say or is a keyword in SQL also, and I will say name equals Neymar Jr. So I'm saying when name equals Cristiano or name equals Neymar Jr. So if there's any player in the table who has the name Cristiano or Neymar Jr., he is going to be displayed. So if I run the command, now we see that one name is displayed, Neymar Jr. with the jersey number of 10, because even if the first condition name equals Cristiano does not match any record in the table, the second condition name equals Neymar Jr. matches a condition. And instead of using the or, we can also use and. So in this case we are going to be checking if, or we are going to be selecting players with the name Cristiano and Neymar Jr. at the same time. Since we know that players don't have 2 name attributes, I am going to cancel the first condition and replace it with something else that can relate or that can function in our example. So I will be checking the first condition will rather be where the jersey number equals 7. And remember, as I said, for numeric values we don't need to use the quotes, whether single quotes or double quotes. So let me run the command again, and here we can see that nothing is returned to us because there is no place or no player in our players table who has the jersey number 7 and the name Neymar again. So we have somebody with the jersey number 7 but with the name Cristiano Ronaldo, and we also have somebody with the name Neymar Jr. but not with the jersey number 7. Not the 2 conditions are met, but if we change jersey number to 10 for example, now we see that something is displayed because there is somebody who meets both criteria in our table. Now let me cancel the jersey number and and name conditions. And now let's say if in our table we want to select all players who have a given set of letters or characters in their name, or any set of characters in any of the attributes that are found in the players table, we can do that using something known as wildcard, and that is going to be done using a keyword which is the like keyword, just like a like on a social media post, for example. Now let's say I want to select all players from our table whose name begin with the letter N, like Neymar, for example. So in that case, I'm going to write my same command, select name, jersey number from players. This time around my condition is going to be where name, and then I will write like, and after like I will write a set of single quotes, and within the single quotes I am going to write the letter N, capital N, and followed by a percentage sign. So what this means is that I am selecting from players table all players whose name begin with N. So when I write N followed by the percentage, it means I want all players whose name begin with the letter N and then has anything after N. So that is what this command means. And if I run it, we are going to see that we will be returned Neymar Jr. again. In the same way, I can also precise more characters after N. Like for example, let me say N-E-Y. We see it's still Neymar. But if I say N-A-M, for example, there is no player whose name matches this, and we are going to have nothing returned. We see nothing is returned now. And also we can use other attributes apart from the name. We can also use the date of birth. For example, if I want to see all players who are born in 1992, for example, or who have 1992 in their date of birth, I will first change the name. I will say where date of birth DOB, like 1992. We know that the date of birth continues after this, but we are ending only at 1992. It's going to check or take into consideration only the year, and we see Neymar is returned again. Now instead of checking from the start or checking players whose name or date of birth have a given set of characters at the start, we can also check characters at the end or around the ending of the name. For example, we are trying to check all those who are born on the 5th of a given month, or who have 05 as the last ending characters of their date of birth. So I can say where DOB for date of birth, like, and instead this time around I will come after my percentage sign, not before, and then I will write 05. So I'm checking here all players whose date of birth end in 05, not begin with 05. That is the difference between the two. So if I want to check characters before or at the start, I write the characters before the percentage, but characters after are written when we want to check attribute values which end with these characters. Now let's run this again. Now we see Cristiano Ronaldo and Neymar Jr. because both of them were born on February 5th, which have 05 in their date of birth. And I can also check for another attribute, like let's say the jersey number. So instead of date of birth, I will write jersey and number, and then I will say I want to check jersey numbers which end with 0. I will write the 0 here, and now we have the different players who have the jersey number 10 which ends with 0. And then now if you want to check characters or values which have characters not necessarily at the end or at the beginning of the attribute value, we can also write the characters between two percentage symbols. So when we are checking before, we write the characters before the percentage, and after we write the characters after the percentage. But we can also write characters between two different percentage symbols. We want to check or select all players from the players table who have any attribute whose value matches the characters that we are going to write inside here. Like for example, we are going to write, or we are selecting the name of any player which has the sequence of characters MES inside. And now let's run this. We see we are returned Lionel Messi because inside the name Messi we have the sequence of characters MES. As we can see, MES is not at the start of the name Lionel Messi, and it is not at the end of the name also, but it is just found in between the name somewhere. So that is why we are writing between two percentage symbols. But if you write and remove the percentage at the end, it is going to mean we are trying to look for names that begin with MES. And now the final thing we are going to see about select command is how to select data in a range. Now we can see we are going to use this to select data with attributes found in a given range of numbers or letters, for example. So for that, we can, for example, try to find all players whose jersey numbers are in the range 5 to 8, for example. So I will select the name and jersey number still from players table, where this time around the jersey number is in the range. So to specify the range, I will use another keyword which is between. So I'm saying where jersey number between, and I will write the range now, which is going to be between 5 and we write the keyword and in full and 8. So I will select all players whose jersey number are between 5 and 8, and we already know who that is going to be, Cristiano Ronaldo with the jersey number 7. We can also change the range and put between 10 and 15. And now we see Lionel Messi and Neymar Jr. And now I'm going to delete or cancel this entire select statement, and we are going to now see something different. Let's now see how to modify values of given attributes in a table. Now, for example, let me start by selecting our entire table. I will say select star. I said when we write the star, it means we are selecting all the attributes or all the columns from the table with their values. And I will say from players. So we get our entire table being displayed with all its data. So let's see an example in which we will be trying to update or modify the name of a given player in our players table. Like we are going to be changing the name Cristiano Ronaldo to CR7. To do that, I will use a command which is known as the update command. It begins by writing the keyword update, and after update I will give the name of the table which I want to perform the update on, which is the players table, and followed by a keyword set. Now I will give the attribute of the given player which I want to update, and this is going to be the player's name. So I will write name equals, I will give the new value of the name within double quotes or single quotes, and I will say CR7. Now after writing this name which I want to update, I need to choose a particular row in our table which I want to update. It can be the row with ID 1, 2 or 3. So I will say where is the keyword used to choose or select or specify any condition. Now the condition is going to be where the ID equals 2, and I will remember my semicolon at the end. So our MySQL is first of all going to find the given player with ID 2, and then is going to then perform this update on the name attribute. Now let's run this to see the difference. So our update is successful. I will run my select command again, and now we see the update has been made. We have the first player is Lionel Messi, second CR7, and third Neymar Jr. Now let's also update another attribute. I will also say I want to change the, let's say, jersey number. I want to change the jersey number of Neymar Jr. from 10 to 11, for example. We know he has also been iconic with the 11 jersey number, and I want us to have just one number 10 in our database. So I will change jersey number to 11, where ID is equals to, I will say where ID equals 3 because Neymar is in the third position, and I will run this. Now if we select again, we see Neymar's jersey number has been changed to 11 from 10 to 11. So when trying to update a given piece of information in your database table, you make sure that you always use the primary key of the table in order to select the row which you want to perform the update on, because using another attribute which is not the primary key might have repeating values, and it will cause problems in trying to identify the particular row you want to perform the update on. So generally it is good to use the primary key attribute to choose or write the condition where you want to perform the update on. Okay, so far we have seen how to create a table, insert data into it, and we have even seen how we can modify data in a given table. Now I want to also show us how we can delete data from a table. We can delete data from a table using the delete command in SQL. So I will first cancel this line of update, and then I'm going to write the delete command which begins with the keyword delete, and then after delete I will say from, then give the table which I want to delete from, and my table is the players table. And after writing the table name, I will now write which particular row I want to delete from this table. So I will use the where keyword to give the condition. The condition is simply what indicates the given row I want to delete. I can use something like the ID, so I will say where ID equals and give a given ID like 3 if I want to delete the player with ID 3, for example. So this is how we delete a piece of data from our database table, and I will just run this. We see that Neymar is the player at ID 3, and that is what's going to be deleted. And now if I select from players again, we see that this time around we have just 2 players, Lionel Messi and CR7. There is no longer any Neymar Jr. there again because we have deleted him from our database already. Now I will run my insert command, which has the insert where I inserted Neymar again to insert back this record in our table. And if I select the players table again, you will see that he is inserted back into the table already. So that is how we can delete a given row from a database table. We already saw how to delete an entire table using the drop table command, which I said is written as drop table, and then we write the table name which is players. And we can also delete the entire database, which is going to be drop instead of table we have database, but I will not do all of this because I don't want to delete the database. Now we are going to talk about foreign keys in databases. A foreign key is a particular column in a table or a particular attribute on a table that is the primary key of that given table, but is also found or used on another table in our database. So in order to illustrate the use of a foreign key, it means we will need to create a new table in this database. So we have only the players table currently, but we are going to create another table which is going to be a table that shows the teams of each of these different players. So I'm going to create a new table using the create table command, and the name of this table is going to be national teams, because I want this table to show the different national teams in which each of these players we have play in. So I have said national teams, and by the way, I'm precising national teams because I want to be the national teams exactly, because we know that national teams do not change, whereas if I use club teams, they might change in future, which will be a bit weird to watch in this video again. So I will say national teams with my parentheses, of course, and here I'm going to then define the attributes of this given table. So I will first have an ID for each national team, and it is going to be of type integer. It is going to be an integer ID also, and I will give this the attribute primary key to specify that this is my primary key. And then the next is going to be the team name, which is going to be a voucher, as you guessed, and I will give it a size of 100 characters, even though that's too much, I know. And after that we will have the player ID, and it is going to be of type int. So this player ID we have here is going to reference the ID of the individual players on the players table. So on the players table we have it just as ID, but on the national teams table, since we already have another attribute called ID, we cannot call it ID again. That is why I've attached player before it, so it is now player ID, but it is going to have the same values as the ID of the players table. And in order to precise to MySQL that we want this player ID to be attached or linked to in a way to the IDs of the players table, we need to write it or specify it as a foreign key. So for that I will write the keyword foreign and then key. Then within a set of parentheses I will write the attribute which is a foreign key on this table, which is going to be the player ID. And after that I will say references. This is another keyword, references. Now I will write the table which it references an attribute into, players, and inside my parenthesis still I will write ID, because ID is the particular column in the players table which we are referencing here. So I'm saying player ID on the national teams table is a foreign key, and it references the ID of the players table, meaning that the values of player ID on this table must be existing on the players table in the ID column also. So that is what a foreign key means, and I will remember my semicolon at the end of this. And also one thing I want to also show is how to use another attribute in our table, which is the auto increment attribute. So I can come to the ID integer primary key. After giving the data type integer, I'm going to add another attribute before primary key, which is going to be auto increment. Sorry, it's not supposed to be separated. There is supposed to be an underscore linking auto and increment, and that is how we write it. So the auto increment is an attribute that we write or we give to a given column if we want the values of this column to be incrementing automatically without us having to give new values for it manually. This is useful especially for numeric values like the ID we have here. Like if we see in our example with the previous table, we had an ID on the players table, and each time we create a new player we need to give a new ID to this player. But with the auto increment, what we will do is we will only need to give an ID for the first row in this table only, which is going to be the first team, the first national team. But for other subsequent rows which we are adding, we will not need to precise or specify their values again, but it is going to automatically increase its value by adding 1 to the previous ID that was already there to form the new one. Like on our players table we had Messi, who was player 1, and Cristiano was player 2, but when we wanted to add Neymar we still wrote 3 again. Whereas if we had used auto increment, each time we are inserting a new player, like inserting Neymar here, we will need to insert just the name and other attributes, but the ID will take care of itself automatically. So that is what the auto increment helps us to do. So I will run this command now to create our new table called national teams. Okay, and now that we have created our national teams table, let's also display what is on this table. So I will select all from table. This time around I will change players to national teams, and let me run the command. Now we see our national teams table is displayed, but there is nothing inside yet because we have not inserted any data into it for the moment. And by the way, before we continue, I want us to also take a look at some SQL data types which we did not see. I was supposed to show this when we created the first table, but I forgot, but it's still an opportunity to show you now. So we have different data types which we have already used, and even some which we have not yet used in our video. Like we have the ints. We already know what ints, varchar means. These are what we have already used so far. But we also have other data types like the text data type. As you can see, I've written the descriptions for each. Text is a variable length string for large text fields. It's similar to varchar, but just that it's able to store a lot more characters than the varchar, like entire comments or entire paragraphs, if you want to think of it like that. And we also have the decimal, which we have already seen for storing decimal values. But similar to decimal, we have other data types for storing decimal values like float and double. So the main peculiarity with float and double is that they are data types used for storing decimal values, just like the decimal which we have already seen. But when using the float or double, you don't precise a fixed amount of digits to be used for your value or for your decimal values. Like let's go back to our table or our players table which we created. We see that when we use the decimal here for the height attribute, I said after writing decimal you need to write these values within parentheses, where the 3 represents the total number of digits which are going to be used for your decimal value or for the height, while 2 is the number of decimal places. But when using a data type like float or double, when using any of these two, you don't need to precise all of that. You simply write float or you write double, and then when inserting the values, you can insert as many digits as you want or as many decimal places as you want. It doesn't have any fixed limitation. But the main difference between float and double now is that while float can store decimal values with only up to 7 decimal places or 7 digits after the decimal point, the double is able to store up to 15 decimal places. So double is a lot bigger than float. And after that, we also saw how to use date for date of birth of our players. But apart from date, we also have time for storing time. It stores times as hours, minutes and milliseconds. We can see an example which shows how to use the time here if you want to store time in a given table. And we also have date time, which combines the use of date and the time data types. As we can also see, it has an example. We have a given date. After the date, we have given some space and added the time to it. So those are some other common data types which you might come across in SQL, but which we didn't cover in our example video. But I thought it wise to still show you. Maybe you may use it somewhere else in future. Now let's actually insert some data into the national teams table. So we are going to use or do something similar to how we inserted into the players table. It's still going to be the same command. I will write insert into table name is national teams, and now I have to give the columns which I want to insert in. So the first column is going to be the ID column, comma, followed by the team name and then the player ID. Remember, this player ID is a foreign key that references the ID of the players table. And I will go to the next line now and write values. And remember, as I said earlier, separating into different lines is just by personal preference because I like it to be very readable. Now for the ID, I'm going to give the ID of 1 for the first national team, while the team name, I think the first player was Lionel Messi and his national team is Argentina, so I will write Argentina. I'm just writing the country names for the national team names. And after that, we have player ID. I'm going to give a player ID of 1, and I will remember my semicolon at the end of this. Now, since we gave the player ID as a foreign key and we said it references the ID attribute of the players table, this means that if we give a value like 1, which we have given here, if this value is not existing in the ID column of the players table, it is going to cause an error. So this foreign key simply ensures or makes our table to ensure that any value we give as value for the player ID should be a value that is already existing on the players table. For example, if we give a player ID of 100, we know that there was no player with an ID of 100, and so trying to create a national team and giving a player ID of 100 attached to this team is going to be false or fake, which will cause an error. So let's try to run this and we will see. We see that we get an error, insert international teams, and the error is simply because the foreign key is an invalid value. which is 100. But if I change this 100 to 1, 1 is a value that exists in the players table, and it is going to work this time around. And now we see it shows a success message. Now let me now change the values to insert a second national team. So as I said, since we use auto increment for our ID attribute, it means if we want to insert subsequent players, now we don't need to precise the IDs again for these teams. It's simply going to increment itself. So I can remove this ID column from here because we will no longer insert an ID value. But if we can see once we can insert a value, it is going to insert manually. But the aim of auto increment is that even if we don't insert manually, it is going to insert itself. And I will also remove the ID which is inserted in the values. So now the only things I have to insert are the national team name and the player ID of any player who plays in that national team. I'm going to insert another team name which is Portugal for our second player, and this is going to have the player ID of 2 to show that there is a player with the ID of 2 in the players table that plays for this team. And now we see Portugal is added to the teams table, and it has one player who is Cristiano Ronaldo with the player ID of 2. Now let's select from national teams and see what is there so far. We can see the two national teams which we have added, Argentina and Portugal, with player IDs 1 and 2. So now we have already created a second table called national teams, and we have inserted 2 rows in this table already. Now let me show you how we can also insert multiple rows in a given table using a single insert command at a time, instead of having to run one insert command to insert one row and then come back and modify the values. So in order to demonstrate that, I will first start by deleting the national team called Portugal from our table. I will say delete from national teams, where the ID was Su, so I will say ID equals Su, and I will run the command. Now we have already deleted the national teams with ID equals Su because I want to reinsert it back again at the same time as the third national team. Now after that, I will come back to my insert command. I will insert national team with name Portugal again, and I will give it the player ID 2 because it is linked to the player with the ID of 2. And before the semicolon to mark the end of this command, I will write a comma, and then I can give spacing if I want. Then I will write a set of parentheses again to add a third national team at once. So the national team I'm going to add next will have the name Brazil, and it is going to have one player which is the player with ID 3. So now we have 2 teams which we are adding at the same time, and I can add as many as I want, but for now I will add just these 2 because in our players table we have just 3 players, and I think we have already used all the 3 players. And I will run this command. Now the 2 national teams have been added. If I go to my national teams table and select it again, now we see we have 3 national teams inside, and notice that the IDs are 1, 3 and 4. This is because we first had a national team with ID 2 and we deleted it, so 2 is not going to be used again here. And now let's add some other national teams just with the team names, even if they don't have any player IDs to be used for them. So I will come to my insert into national teams command, and then I will insert only into one column, and for the values I will give only the national team names. So I will add another national team which is Cameroon, and it does not have any player ID, so I will move this. Same thing below, and the last one is going to be France. Now I can run this command again, and it is inserted successfully. If I run our national teams table again, now we see we have 5 national teams, but the IDs are 1, 3, 4, 5, 6, and we can see the last 3, or the last 2 rather, they have null values for the player IDs because they don't have any players in the teams yet. Now let us talk about something else in SQL, which is a join. An SQL join is a way of selecting values from 2 or more tables at a time using a specific attribute or column which they have in common. Like we can see in our players table, we had the player IDs, which is the primary key, and then in the national teams table we also have another column which is the player ID, which references the ID of players in the players table. So that is an attribute the 2 tables have in common, and we can make use of this attribute or this foreign key to then display or select values from the two different tables at once in one single select statement. So in order to select from multiple tables at once using a join, we are going to see that in this example. So let's say I want to select the name of a player and the national team of that player, or rather I'm going to select the name and jersey number of every player from the players table, and then I'm also going to select the national team names from the national teams table at once using the same select statement. So far we have been seeing how to select from a single table at a time, but now we are going to see how to select from multiple tables. So I'm going to write my select command, and then now I want to select the names of the players. Since I'm selecting from more than one table at a time, I need to first precise the table which I want to select an attribute for, which is going to be the players table, and then I will say players dot name and write a comma. Then I will say players again. I want to select the next attribute from the players table. I will say players dot jersey number. Now I want to select a third attribute, but this time around the attribute I want to select is going to be from the other table, which is the national teams table. So I will say national teams dot, I think their name was team name. Let me make sure that it is correct. Yes, it is team name. And after that I will go to the next line to make the command more readable. As I said, you can give as much spacing as you want, and I will say from players. So the main table I want to select from here is the players table, while the national teams is just an additional table that I'm adding to the players table. And after that I will say joins. So this is where I'm precising the join now. I will say join teams. So what I'm doing here is that I'm selecting from two different tables at once, player.name and players.jersey number with national teams.team name. You can see that these three attributes we are selecting are across two different tables. Now I will say from, when I say from players, it means I want to select primarily from players table, and then I will simply join the next table, which is going to be national teams. Sorry, it is not just teams. So I am selecting from the players table, but I am also joining or adding national teams to this players table, and I will add another keyword which is on. Now after writing on, I'm going to say or precise the common column that these two tables have. So for the players table we have a column which is the ID, so I will say players dot ID and equal to, in national teams we also have a column which references the players dot ID, which is national teams dot player ID. Okay, so it is okay like this, and I will add a semicolon to mark the end of this command, and if I run this now we will see what the result gives. So we can see as the result is displayed, we have the name and jersey number of every player on our players table, and then after this we also have a third column which shows the national team of each of these players. For player 1 we have Argentina, then Portugal, then Brazil. So that is how we have selected from multiple tables at a time. We can also use this same method to select from 3 tables and above even. Now this type of join we have seen is a normal join, which is also known as an inner join, and it is written by writing just join keyword. And what the inner join does is that it simply gives only the rows which have values for both attributes in both tables. So we have other joins also, which are the left join and the right join, and let's see how to use them to see the difference between all of them, even though it is not a very big difference. So for the left join, I will keep everything just as it is already, and I will write the keyword left before the join keyword, and they are separated by a space. So with the left join, the difference between the left join and the normal join is that when we say left join, it is going to first select or display all the values from the players table. Since we are selecting their names and their jersey numbers, it is going to display all the player names and jersey numbers first before simply attaching the national team names to each player which has a national team. Of course, in this table all our players here have a national team, so we are not going to see much difference between the left join and the normal join here, but when seeing the right join we will see the difference better. Anyway, let me just run this, and we see we get the same result as with the normal join. But if I change this to right join now, so I'm going to change left to right, and now it is a right join. So now with the right join, the difference is going to be that we will first display all the national team names only, and then after that we are going to simply attach the player name and the jersey number of each player who belongs to a given national team. But even the national teams without players are still going to be displayed. So we saw with the left join, we didn't really see the difference between the left join and the normal join, because the left join also displays all the player names and jersey numbers first, and then each player with a national team, his or her national team, is simply attached to the player name. But all the players already had national teams, that's why we didn't see much difference. But with the right join, we are going to see the difference better. So we see here all the national team names are displayed, even those without players in those teams currently. We have the first 3 players, but we have up to 5 national teams because the last 2 don't have any players attached to them. So that is how to use joins to select data from 2 or more tables at a time in MySQL. Now the next thing we are going to talk about in this video are aggregate functions in SQL. So what an aggregate function is simply a function. There are many of them. In fact, they are simply functions that we use to perform given calculations on data in our table. Let's see some aggregate functions in an example to see what they are all about. So we will first start by selecting from our players table. Let me display the players table first. Now we have our players table, which is displayed. All the columns and the rows from this table are shown. Now we can use aggregate functions to perform various operations on the values or on the data values of this table. For example, I may want to count how many players are in this table in total. It's easy to count 1, 2, 3 because there are very few players on this table currently. But let's say there were hundreds of players on the table and we don't have time to count one row after another. We can simply use an aggregate function that is a function provided by MySQL to help us count rows on the table at once. So to do that, I will say select. The name of the function is going to be count, and then I will write in bracket the column name which I want to count. Let's assume we simply want to count all the players in this table, so I can use any attribute like ID, or I could even use name here. So I'm counting the player IDs, which counts the number of players that are on the table. And then I will say from the name of the table is players. Now I will run this, and we see it gives us the answer 3 because we have counted the IDs. Instead of ID, we could also use a star here to say that we want to count all the rows, not based on any single column, and it's still going to give us 3. And we see we still get 3. So the count function is a function or an aggregate function in MySQL that helps us to count number of rows on the table. Now if you go back to our players table and display the entire table, we also see that we have an interesting column which is the jersey numbers. Let's say these jersey numbers, I want to sum all the jersey numbers on this table. This is going to be 10 plus the second, which is 7, that's 17, plus the third 10 again, that's going to be 27. So I can also use a function to sum all the values of the jersey numbers like that. Instead of count here, I'm going to change count and write sum. Instead of the star also, I will write the name of the column whose values I want to sum. So I will say I want to sum the jersey numbers, and it's supposed to be inside or within parentheses. So I'm summing the jersey number from players, and this is supposed to return us a value of 27. We see 27 is returned, the sum of the jersey numbers. And we can also use an alias here. So I will say I want to return the sum of the jersey number as, I will say as we said, we already saw aliases and what they do. I'm going to say I want to return this as, instead of having this column name sum jersey number here, I want to have a better name. So I will simply say total, and I will run the command again. Now we see total 27. instead of some jersey number 27. And now what if I wanted to find the average of all of these jersey numbers? So I'm going to change the sum function. We also have another aggregate function which is average, that simply returns the average of the numbers. So the total is 27. We are going to now take 27 divided by 3 to have the average of all of these numbers. So let's run this, and it gives an error, average does not exist. Sorry, I made a mistake. The name of the function is not average, it is average, but it's not written in full. We actually just write avg instead of average in full words. Now I will run this again, and it gives the average of all of these numbers to be 9. That is because the sum was 27 and it has divided it by the total number of rows, which is 3. So 27 divided by 3 obviously gives us 9. And now let's say we want to find the max or the maximum of all of these jersey numbers. I can use another function again, which is the max function. And if I run this, we see the max is 10 because we did not have any jersey number that was above 10. And if I write min also to find the min, it is going to be 7 because the lowest number there was 7. Okay guys, so we can see there are a lot of functions like that provided by SQL. We are not going to go through all of them because it's going to take forever. I want to show those the most essential ones. And with that, we come to the end of this MySQL crash course. If you had any questions while watching the video, make sure to ask them in the comments and I will do my best to reply. And also please remember to like and subscribe to the channel so that you can keep up watching other videos that I will post in future.